Welcome to chapter 10. We'll be looking at the environment this chapter, and we're going to learn a lot of different ways on how the environment affects plant growth. So here is our outline. So these are the 5 major points that we're going to talk about for this chapter. We're going to learn about the sun's energy, the atmosphere, different climates in North America, precipitation and temperature and how that affects what we grow in different parts of North America, and then how do we manage all of the environmental resources that we have, or how do we manage things like drought, floods, different climatic changes that we have within agriculture. So just some key concepts that I want you to take away from this. The big thing is that our sun is a huge force behind our climate. So it's going to dictate how, not just how hot or cold our air is, but it's going to dictate a lot of other things as far as wind, as sun, how much rain we could get or not get, or how much could be then sucked up through roots and then back up into the sun, like the water cycle that we'll talk about. Quality, duration, and intensity, very, very important for the influence of different plants. We'll look at climate and how it's typically a long-term weather in a region. So we'll look at the difference between climate and then weather. Precipitation and temperature, and how those are 2 extremely important factors in agriculture, not just in the plant world, but in the livestock world as well. And then how we select crops, how we manage residue like wheat straw, how we fallow, how we irrigate, how soil drainage is important for all of those management practices. So let's look at the sun's energy real quick. So if we did not have the sun, we would not be here. So we would not be able to live without the sun. So life on Earth is extremely dependent on the sun and the energy that it puts out. One big important fact that I hint want you to know is that less than 1% of the total energy generated by the sun reaches the Earth's surface. Okay, so just imagine how much more heat, how much more waves are actually being given from the sun that is not reaching the earth. Okay, so about 50% of that is absorbed by the Earth's surface. Okay, so it might not directly hit us, but it's going to be absorbed by the surface, especially within the ocean. So how do we look at the sun's energy? How do we measure that? It's in bundles that we call photons and move in waves. Okay, so if you're a big fan of the Big Bang Theory, you've heard photons before, and then we'll look at the waves as well. So this is in your book, but I wanted to talk to you about it. So you can see the sun up there, and then those arrows that are pointing to those rays from the sun. So you can see visible light, that's what we see, okay? Infrared, ultraviolet, X-rays, microwaves. You can probably remember, if you're going to be in a climate that has very little trees or is very, very hot, like a beach or something, those infrared waves or ultraviolet rays are kind of dangerous. And so how do we fix that? How do we protect ourselves? Sunscreen, stuff like that. So that is really important in terms of how we measure those sun waves. And then if you look at the wavelength, you can look at violet to the red wavelength and measure that. We measure that in nanometers, and we're going to look at that in class this week. But that's really important to the visible light in comparing it to the ultraviolet and the infrared that we get from the sun. And then if you go to the extreme violet wavelengths, you'll look at the cosmic rays waves, the very extreme red. We look at the radio waves, which is a really good song by Eli Young Band. So let's now look at seasonal and day length effects. Okay, so really important for the different seasons that we have on this earth. So again, the sun is going to orbit the earth, in a one calendar spin. So the daily spin of the earth is then going to interact with the cause of variation. That's what's giving us the nighttime versus the daytime. But our full calendar year or our different seasons has to do with the tilt, or what axis the Earth is on. Okay, so we have two spring and fall equinoxes. We have March 21st and September 21st, and that's probably in your brain because that's kind of when officially summer begins and fall begins, September 21st. So it's because of it has an equal amount of those solar radiation that reaches the north and the south hemispheres that we have. And then the winter solstice, we look at December 21st, and then the summer solstice is June 21st. So that is technically when summer starts. So the spring is the 21st, the fall is the spring, is March 21st, the fall is September 21st, winter is December 21st, and summer is then June 21st. So that is kind of how we dictate when all of those seasons fall. And here's a picture of that. This is also in your book, I believe. So now let's look at light effects on plants. So we know the tilt, and we know the different equinoxes, fall, spring, summer, and winter, but how does that affect what we grow? Well, the big of these big three, the light quality is really important, because we need the wavelength of light that is superior, or that will help that plant grow to its to its greatest ability. So we talked about in these last couple slides how those nanometers are really important. So that plant, in terms of light quality, needs to have a peak absorption of 420 to 460 nanometers, and depending on the crop, 620 to 680 nanometers in wavelengths. Okay, so if you look in your book, I think it's around page 231, you can see those nanometers and how they will affect the rays that are coming from the sun. And then light duration, we look at that specifically because of the respond to changing day lengths. Okay, so if I plant a corn crop in March, the day length is going to be different than it's going to be in June. Okay, it's going to be a longer day in June. So we have to look, that plant has to then respond to how much sun, how much sun it's getting throughout the day, because it's going to be very different from the March, April to June, July. And that's really important to look at in terms of varieties and hybrids that we breed. And then light intensity, we're looking at the quantity and the brightness of that light, which is really important, because that quality is all about the wavelengths of the sun. And then it also is a big thing with chlorophyll, because the pigment will then respond to that light absorption, then in turn giving us more photosynthesis. But if we're getting photosynthesis at the wrong time, or if we planted really late or if we planted really early, that could really affect the way our plant is photosynthesizing. That chlorophyll is in interaction, and how that is all being done. So all of these three are huge effects on plants, like quality, duration, and then intensity. Okay, now let's look at our atmosphere. So when we look at our atmosphere, one big thing that I want you to wrap your mind around is that our gas layer extends up to 70 miles within our atmosphere. Okay, so you would be, there's different gases obviously within those 70 miles, but we compose it within four major spheres. Okay, and those four major spheres then have different functions. So like protection from the different wavelengths, we have temperature regulation, which is really important, the passage of that radiation and how much is actually getting to the earth, and then water vapor, water absorption as well. So here's the layers of the atmosphere that we have within the earth. You can definitely tell if you look at that altitude. This is in the left is kilometers, and then the right is miles. Okay, so if you look up 70 miles, that temperature is obviously going to change depending on where you are on Earth. Okay, Alaska is going to be a lot different than anywhere in Texas. Okay, so those layers are gonna be evaluated differently because of the tilt that the Earth is on, and because obviously of the climate of that region.